Somewhere in New Jersey in the summer of 1965, two radio engineers kept hearing a hiss in their antenna that would not go away. They pointed the dish at empty patches of sky. They pointed it at cities. They even climbed inside and scraped out pigeon droppings, thinking that was the problem. The hiss stayed exactly the same, no matter where they aimed, no matter what time of day it was. What they had actually stumbled onto, completely by accident, was the afterglow of the Big Bang itself, light that has been traveling across space for almost 14 billion years. Scientists call it the cosmic microwave background, and in a very real sense, it is the oldest light there is. That accidental discovery turned out to be such a big deal that it eventually earned a Nobel Prize for essentially finding proof that the universe really did begin in a hot, dense explosion. Here is a strange thought to sit with for a second. If you have ever seen static on an old analog television, a tiny fraction of that fuzz was genuine light left over from the birth of the universe. So once scientists knew this ancient light was out there, coating literally every direction of the sky, the next question was obvious. What does it actually look like in detail? Getting a clean picture took decades. One satellite mapped it roughly in the late 80s and early 90s. A sharper one mapped it again in the 2000s. A third, even more precise, finished the job in the 2010s. When scientists finally had a map good enough to study closely, they expected it to look almost perfectly smooth and random in every direction, the same texture no matter where you look. That is what the leading theory of the universe predicts. No special direction, no special spot, just uniform statistical noise stretched across the entire sky. Instead, they found a handful of strange patterns that, according to that same theory, really should not be there. One patch of the sky turned out quieter than it should have been. Two of the largest structures on the map lined up in a way that looked almost deliberate. One half of the sky behaved differently from the other half. Scientists lumped these strange patterns together and called them the CMB anomalies. They even gave the strangest one a dramatic nickname, the Axis of Evil, just because of how oddly aligned it seemed to be. So what is actually going on here? Is the universe hiding something enormous, some clue about its shape or its earliest moment? Or is this something far less exciting, just a smudge on the camera lens? Have you ever wondered how you would even notice a smudge on a photograph of the entire sky? Picture trying to photograph a perfectly dark room, except a bright lamp is sitting right in the middle of your own camera. That lamp is our own galaxy, the Milky Way, glowing with dust and radio noise directly in the foreground of every picture we take of the deeper universe. Before astronomers could even start hunting for anomalies, they had to somehow paint over that glow without smearing the faint, ancient pattern hiding behind it. For years, the safest way to do that was to simply black out the brightest part of the sky entirely, roughly a quarter of the whole map, and only study what was left. It worked, but it also meant throwing away a lot of real data, and always wondering, quietly, whether that missing quarter was hiding an explanation for the weirdness in the rest of the picture. Meanwhile, the anomalies themselves kept raising bigger questions than most people realize. If the universe really does have a preferred direction, or a patch that behaves differently from the rest, that would break one of the most basic assumptions in all of cosmology. The idea that the universe looks roughly the same everywhere and in every direction. Physicists have floated some genuinely wild explanations over the years. Maybe the universe is not infinite and flat, but wraps around on itself like the surface of a strange cosmic donut. Maybe the very early universe expanded a little differently than the standard story says. None of those ideas have ever been confirmed, but none of them have been fully ruled out either. And that is exactly why these 5 odd patterns kept showing up, mission after mission, for more than 20 straight years. It is worth asking, too, why anyone should care about ripples this tiny in the first place. These patterns are frozen snapshots of the universe when it was only a few 100,000 years old, unimaginably younger than it is now. Whatever shaped those ripples back then left fingerprints that are, in principle, still readable today, billions of years later, if you know exactly where to look. 3 completely different satellites, built by different teams, using different instruments, all still saw the same handful of oddities. That kind of consistency is hard to wave away as a fluke, and it is also exactly why so many scientists have spent 2 decades arguing about what it actually means. If stories like this, real scientists quietly chasing down a 20-year-old cosmic mystery hiding in plain sight, are the kind of thing you enjoy, hit subscribe. We go looking for a new one every week. So what exactly are these 5 strange patterns? Let's walk through them one at a time, because each one is a little different from the others. The first anomaly is almost embarrassingly simple to describe. Compare any 2 points on the map that are far enough apart, and the pattern between them should be a little bit similar, on average, the way weather in neighboring towns tends to be a little bit similar. On the largest scales, that similarity was weaker than expected, almost as if the largest ripples in the early universe were missing some of their expected strength. The second anomaly involves a kind of cosmic symmetry. Flip the whole map through its center point, and it should look statistically the same as the original. Instead, one type of pattern showed up slightly more often than its mirror opposite. The third is the famous axis of evil. The 2 largest ripples on the entire map, the biggest brushstrokes in the whole painting, pointed in almost the same direction, when random chance says they really should not. The fourth showed up when researchers split the sky into a northern half and a southern half. One side was noticeably calmer, quieter, less varied than the other. And the fifth was a broader version of that same idea, a kind of lopsidedness in how much the temperature wobbled from one region to the next, measured in small patches scattered all across the sky. Individually, none of these 5 patterns are dramatic. Each one is only moderately unusual, a coincidence that could plausibly happen once in a while by pure chance. But 5 separate coincidences, all pointing at the same rough conclusion, spotted by 3 unrelated space missions over 20 years, is a lot harder to shrug off. Now, back to that lamp sitting in the middle of the camera, because it turns out somebody finally found a clever way to deal with it. For years, cleaning the map meant guessing at the shape of the galactic glow and subtracting it out, then blacking out whatever was left over as a safety margin. A newer approach instead compares the sky against a whole stack of older reference maps, going all the way back to some of the earliest satellite surveys of the galaxy, plus a decades-old radio map of the Milky Way, to figure out exactly which parts of the globe belong to our own galaxy and which parts are genuinely ancient light. Done carefully enough, that method needs to hide only a tiny sliver of the sky instead of a full quarter of it, to get an equally clean signal. Have you ever wondered whether that missing quarter of the sky was secretly hiding the answer the whole time? A research team decided to actually check, rerunning all 5 of the classic anomalies using this newly cleaned, much more complete map of the sky. What they found split the mystery cleanly in 2. 2 of the 5 anomalies got noticeably weaker once the bigger, safer blackout zone was replaced with the smaller one. The oddly low similarity between distant points on the sky and the lopsided wobble between different patches. Both dropped from a moderately strong signal, roughly a 1 in 300 fluke, down to something a lot closer to ordinary, roughly a 1 in 20 fluke. In Blaine terms, a real chunk of what looked like a genuine cosmic mystery turned out to be tangled up with how much of our own galaxy scientists were forced to erase from the picture. The other 3 anomalies barely moved at all. The axis of evil, that suspicious alignment between the 2 biggest structures on the map, held firm no matter which version of the sky was used. The quieter half of the sky stayed quieter. Only the mirror symmetry oddity was ever mild to begin with, and it stayed mild throughout. So is the mystery solved? Not exactly, and the researchers themselves are careful not to oversell it. To get a sense of how unusual these patterns really are, the team built 100,000 fake, perfectly ordinary universes on a computer, ones with no anomalies built in at all, and checked how often patterns this strong showed up in those just by pure chance. A moderately unlikely coincidence is not proof of anything on its own, especially since these 5 patterns were only singled out as interesting after they were already spotted sitting in the data, which tends to make ordinary coincidences look more impressive than they really are. To be taken seriously, they argue any wild new theory about the shape or history of the universe would have to explain several of these leftover patterns at once, not just quietly claim the one that still looks unusual this month. For now, roughly 2 out of 5 ancient cosmic puzzles have quietly lost most of their mystery. The other 3 are still sitting there, unexplained, waiting for whoever looks at the sky next.